Let's go and take a look at chapter 5.2.5 problem. This idea of mutually exclusive. And so here we have a situation where we have the sample space of some experiment. Again, it's just some generic experiment where the outcomes are these numbers for whatever that could be, right? And so the outcomes are 10, 11, 12, all the way to 21. And then we say let event E be the outcomes of 11 through 16. Event F is the outcomes of 15, 16, 17, and 18. And so the question, are these events mutually exclusive? Are E and F mutually exclusive? So again, that goes back to what is the definition of mutually exclusive. So what I see in this situation, something you want to look at is here is, again, we look at a sample space, meaning here is S, all the outcomes, right? There's S. And inside of S, let me get rid of that real quick. Inside of S, right, you have event E. So there's E, and then you have F. And what happens with E and F is that they share some values, right? S is all of these numbers. E is 11 through 16. F is 15 through 16. So what I see is that E and F share 15 and 16. So they are not mutually exclusive because they have outcomes in common, E and F. There's some commonality between E and F. They have two outcomes in common out of the full sample space. Now, we're going to look at one other problem here, which is 5.2.11, looking at this other idea of complement and the notation of complement, which is this little c. And so in this case, what we're looking at is, if you go back to those pictures here, here is a picture of the full sample space S. Inside of S is E. There's E. The complement of S is, of E, is everything outside of E. So here's E. Everything outside of E is what's called the complement. You have that. That's outside of E. Here's E. Everything is outside of the complement. So in this case here, if this is your sample space, this is E. Your complement of E is everything not in there. So this would be 16 and 17. Because here's your E, here's S. The complement of E is everything that's not in E. Everything that's not in E. So in this case here, 16 and 17 are the complement of E, because they're the only two numbers in S but not in E. This notation here just means empty set. Is the complement empty? That's what it's saying there. It's not empty. It has two numbers, 16 and 17, so we can't use that notation. And then what's the probability of the complement of E? Again, there's only two outcomes, so this would be 2 out of, and then how many are in the full set? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 out of 12 would be the complement of that. And if we need a decimal to 3 places, that would be 2 divided by 12. I get 0.167. And so that would be the probability of the complement. The probability of getting something not in C is 2 out of 12, or 0.167, or 16.7%.